Hello. Is there any questions from anything that we've done this week? Is there any questions? I'm not able. There is a meeting right now. I emailed the Zoom link. If you're not able to get onto My Math Lab, I would go to that meeting and then watch the recording of this one. So anyone who still cannot get on, I would definitely go to that Zoom meeting right now. That way they can get you on before next week when we start the new sections. Right now it's just a review. But I will have the video up on As You Learn. It'll be on the weekly checklist. So if you cannot get into My Math Lab, go to the meeting on Zoom. It's between 2 and 3. If you get done, it shouldn't take long to have them get you on, depending on how many people are there. So then you could come back to the class also. But I think it's more important to go to that. Any other questions? Okay. We'll finish the review section today. So there's no group assignment today. They'll start next Friday. We were working last time with dividing fractions, which then goes into solving equations. So if we had this equation, 3x plus 7 times the quantity x minus 1 plus 2 equals 3x plus 5. The first thing you want to do is get rid of your parentheses. So we could distribute the 7 because we cannot combine these two terms. They're not like terms. But we can distribute. So we'll keep everything else the same. 7 times x is 7x. 7 times a negative 1 is a minus 7. And we'll bring everything else down. So if you can simplify or get rid of parentheses, you want to do that first. Then if there's any like terms on either side that you can combine, you want to do that. So keep everything on one side or the other and combine like terms. Notice there's two terms here, but they're not like. So we won't change this side. But this side has 1, 2, 3, 4 terms. These two are like terms that we can combine. And then we can combine these two. 3 plus 7 is 10x. A negative 7 plus 2 is a negative 5, equal to 3x plus 5. Any questions so far? Next, we need to get the x's on one side and the constants on the other. If you can do it at one time, that's fine. And if you don't have to write like the minus 3 on both sides, you just subtract it over and know that it's 7x. That's fine also. But I want to get the x's to the left, so I'm going to subtract 3x since it's a positive 3x. This drops out. 10 minus 3 is 7x. Now, if you wanted to do the 5 at the same time, you could add the 5 to the other side. I'm going to do it down here. And I'm adding 5 so that this will cancel and leave the 7x by itself. What you do to one side, you have to do to the other. Still trying to get x by itself. Since this is multiplied, we divide it. Any questions on that one? X squared plus 5x minus 6 equals 0. This one's a little bit different because instead of just x to the first power on all of these, we have x squared, which makes it a quadratic. In order to solve one with x squared or any higher power, you first need to get it set equal to 0, and then you want to factor. So we need to factor this. There's no term in front, so we can just find two numbers that when we multiply, we get -6, and we add, we get a +5. So what two numbers when you multiply give you -6 that when you add give you a +5? Anyone?
6 and
6
negative
and
1.
-1.
There we go. When we multiply, we get the -6. When we add, we get a +5. So this will factor into x plus 6 and x minus 1. Now, in order to solve this, we have to use a theorem. If AB equals 0, then A equals 0 or B equals 0. So when you have two things multiplied together, in order to get 0, one of them has to be 0. So we can set both of these equal to 0. And then we can solve them. This one, subtract the 6. And this one will add 1. So we have -6 and 1. Any questions on that one? Okay, again, we have a squared term. So we need to get the quantity or the equation set equal to 0 and then factor. Since it's equal to 1, we need to subtract the 1 to the other side. There's no like terms to combine it, so it's 3x squared plus 2x minus 1. Now this one, notice there's a number in front, so you cannot factor it the way we did this last one. You can use trial and error, factor by grouping, or the X that we used last class. If we use the X, or do it whichever way you like to do it, and then we'll make sure we get the same answer. Should be getting x plus 1 and 3x minus 1. To do that, I need to multiply 3 and negative 1. So 3 times a negative 1 gives me a negative 3. I want two numbers when I multiply give me negative 3 that add to give me the middle number, which was a 2. And that was a positive 3 and a negative 1. Then you take these two numbers and divide by the leading term, which is a 3. This will reduce. You put the x in the denominator, so it's 1x plus 1. Remember, you don't have to show the 1 here, so it's just x plus 1. This one does not reduce. Put the x in the bottom, 3x minus 1. Any questions on that part? And then set each of them equal to 0. And solve. This one will subtract 1 and get negative 1. This one, we need to add the 1 and then divide by 3. So we get 1/3 and negative 1. And if you can go from x plus 1 equals 0 to negative 1 and from this to 1/3, that is fine also. Any questions on that? Oh, in case you're still writing. So this one is set equal to 0, but there's only 2 terms instead of 3. Since it is squared, you still want to factor it if possible. Now we can't factor it into 2 binomials like we did here, but we can pull something out. What do they have in common that we could factor out?
3y.
Pulling a 3y out from the first term, we're left with a y. And then 9 divided by 3 is 3, and we pulled the y out. So we have 3y times y plus 3. So sometimes it's just not your normal factoring. Since these are multiplied, you still can set each of them equal to 0 and solve. First one, this is multiplied by the 3, so we divide by it to get rid of it and get 0. This one, we're adding 3, so we do the opposite, subtract it. Any questions on that? Okay. Okay. In the next group, we're working with fractions. When you have fractions, but you have an equation, which means there's an equal sign, you can multiply through by the common denominator and get rid of the fractions. Anytime you're going to do that, you want to do two things. One, you want to find the domain so you know what values will give you 0 in the denominator. And the other thing you want to do is factor the bottom if possible. That way you can find the smallest possible common denominator. But none of our denominators will factor. This one, if this was a 9, then we could have pulled a 3 out. But since it's not factorable. When you're finding a common denominator, once they are factored, you just take one of every quantity or the largest exponent. In this case, they're all to the first. And so you take each quantity, but don't repeat. So our common denominator would be y minus 3 times 3y plus 8. And you want to multiply each term by that. And there's 1, 2, 3, 4 terms. Before we multiply that, I'm going to find the domain. Domain is any values that will give you 0 in the denominator. And if you can see it without solving it, that's fine. Having your common denominator, you could just use these factors, because if there were ones that were factored in there and written more than once, like this one's written more than once, you only have to look at the 2. And you set both of them equal to 0. And this one, when we solve, we'd add the 3 to the other side. So y cannot equal 3. On this one, we'd need to subtract the 8 to get it to the other side. And since this is multiplied, divide by 3. So y can be any value except for 3 and negative 8/3. When we solve this then, if it's one of these two values, we omit those. Any questions so far? So find your common denominator and then set it equal to 0 to find the domain. Looking at the first group, the x minus 3's will cancel. And then we could distribute the 2 here, or you could write it out. This one, the 3y plus 8 cancels. And then if you are going to distribute here, notice this is a negative 6. So make sure the whole thing gets distributed. The next one, the y minus 3's cancel, and we distribute the positive 3. And then this one, since it's 0, 0 times anything is still 0. If it were a number, you would have to FOIL this and then distribute the number. But since it's a 0, 0 times anything is 0. Any questions so far? Then we just distribute, combine like terms, and solve. Distributing 6y plus 16, then distribute the negative 6. Gives us a negative 6y and a positive 18. And then we distribute the 3, 9y plus 24 equals 0. Combine like terms, we have a 6y, a minus 6y, and 9y. Well, the 6 and negative 6 cancel and just leave 9y. And we have 16, 18, and 24. 20, 30, 40, 50, 58. Any questions? Okay. Again, solving, just subtract the 58. And this is multiplied, so we divide by the 9. Then this will not reduce. So we check this answer and it's not 3 or negative 8/3, so this is a good answer. Any questions on that? Let's try one more. And this one will have one that needs to be omitted, so that way. First thing, this needs to be factored. These two will not factor because they're x to the first power, but this one we can factor an x out. So when we pull out the x, we have x times x plus 4. Common denominator is 1 of everything. If you have a larger power, like if this was x squared, then you take the x squared, not the x. So our common denominator would be x times x plus 4. We don't need to repeat because we already have that. So it would be x times x plus 4. Now, before you start canceling, use that to find your domain. The first one, x equals 0. So if we have 0, we'd have 5 over 0, which is an error. So x cannot equal 0. Now, if you can tell just by looking at them, that's fine. Like if you plug in negative 4 plus 4, that's 0. So we know x cannot equal negative 4. To find that, you're just taking the denominator and solving. So x can be any value except for 0 and negative 4. Any questions on that? Now we go and reduce and distribute as needed. Looking at the first one, the x's cancel. And you can distribute the 5. 5 times x is 5x. 5 times 4 is 20. So you can distribute right here instead of writing it out. That's up to you. Just be careful. The x plus 4's cancel and leave x times x. which is a positive x squared. And this one, x cancels and the x plus 4s. So we're left with it equal to 16. Any questions so far? In order to be able to factor, we know we have to factor because this is x squared. We also need to get it set equal to 0. So it's up to you if you want to do it at the same time. You could subtract 16 and subtract 16. Well, we know x squared has to go first because it's the leading term, and then 5x. 20 minus 16 gives me a positive 4. So you could do it at the same time, or you can put them in order first and then subtract the 16. Any questions on that? We need to factor. It's set equal to 0. There's no number in front of my squared term, so I can multiply to get 4 and add to get 5. 1 times 4. 1 times 4 is 4, and when you add them, you get 5. So it will factor into x plus 1 and x plus 4. Setting each of those equal to 0. And solve. Subtract the 1 and subtract the 4. So we have two answers, -1 and -4. But you need to make sure they're not omitted in the domain. Notice that we can't have 0 or -4. So this one gets omitted. We only have one answer, -1. So anytime you have fractions, you'll have to check for that. When we get into radicals, we'll have to check for that. When we're solving logarithmic functions, we have to check because there's things that are omitted from those. Any questions on that one? Exponents. When you're working with exponents, if you're multiplying the base, you add the exponent. Your base in this case is the x's. So you would add m plus n. When you're dividing, you subtract them. Top minus bottom. When you have an exponent to another exponent, you multiply them. If you have a negative exponent, to make it positive, if it's in the numerator, you move it to the denominator. Likewise, if it was in the denominator, you'd move it up to the numerator. It is not simplified if you have a negative exponent. So when they want you to simplify or give a solution, you should not leave a negative exponent. It should be made positive. There are some cases with derivatives where I would allow you to use leave the negative exponent, but in most cases we will reduce. And these problems right now on MyLabs always reduce to a positive exponent. Square root. When you have a root is a fractional part of an exponent. So this would be x1 over m. Or if we had it would be x to the n over m. And when you have this case, you can either take x to this power and then take the radical, or you can do it the other way. These two mean the same thing. Well, all three do. Okay, let's try some. Five to the negative 3. The first thing I recommend, make it positive first. We have a negative exponent. If we move it to the denominator, it makes it positive. So this is the same as 1 over 5 cubed. And then 5 cubed, 5 times 5 times 5 is 125. Any questions on that? One more, I don't know how I forgot that one, but anything to the 0 power. Doesn't anyone know what anything to the 0 power is? Anyone remember?
1.
So if we had 21 to the 0 power, it would be 1. Anything to the 0 power is 1. These two are not the same. If you want to plug them into a calculator, you could plug them in. You'll see that they are not the same. What the first one is saying is it's squaring both the negative and the 3. So it's negative 3 times negative 3, which is a positive 9. This one is only squaring the 3. It's a negative 3 times 3, which is a negative 9. So you do want to be careful of that. They are not the same. Any questions on that? How about this one? A lot of negatives to think about. I would make my exponent positive first. And when I move it to the denominator, this negative, remember when there's no number, it's a 1. This negative isn't in the quantity, so it doesn't move down. If there was a different number here, it would also stay up there. So it's a negative 1 over negative 3 quantity squared. Negative 3 times negative 3 is a positive 9. So our answer is a negative 1/9. Any questions on that? Okay, there's a couple ways you could do this one. When you have an exponent, you can distribute it to each of them, 1 to the -4 and 2 to the -4. Or if you wanted to get rid of the negative first, when you have a fraction, you can just flip it. Because if we have 1 to the -4 and 2 to the -4, we need to move this down and this up to make them positive. And then 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16 over, since this is 1 times 1 times 1 times 1, you don't have to have that 1 in the bottom, it could just be 16. Doing it the other way, if we use the negative first, it flips the fraction. 2 over 1 to the 4th, and 2 over 1 is just 2 to the 4th, and then 2 to the 4th is 16. I think it's a little easier to understand. It all depends. If this is a quantity with a bunch of negatives in it, you might want to distribute first, depending on your exponents. Is there any questions on that? Okay. When you're dividing, you subtract your exponents, top minus bottom. Which gives us x to the -5. And then you need to move it back to the denominator to make it positive. Any questions on that one? A lot of students had questions that were the ones who were working ahead, had questions on this one yesterday. Yeah, it was this one. Now you cannot simplify these first because the quantity is only on the top. If this was over the whole thing, we could take 10 divided by 5 and get 2. But because the exponent out here, the 4, is only on the top, you have to do that first before you can simplify with the bottom. Most common mistake is to multiply these two and forget that 10 is also going to the 4th power. So when there's no exponent, it's a 1. So this 4 gets multiplied times both of these because they're exponent to an exponent. It's 10 to the 4th and x to the -12th. Now, if you wanted, you could have just put the 10,000 here instead of 10 to the 4th. So 10 to the 4th is 10,000. Now I didn't change anything else yet. Now I can divide these two numbers. And notice these are all multiplication. If there was an addition or subtraction, then you couldn't do that. It's all multiplication, so 10,000 divided by 5 is 2,000. X, and top minus bottom. -12 minus a -2. A negative and a negative is a positive. So it's 2,000 x to the -10. Now, if you plug this into MyLabs, they're going to mark it wrong because you can't keep a negative exponent, we need to move the part with the negative exponent down to the bottom. So we have 2,000 over x to the 10th. Any questions on that one? Now this one, a couple ways you could do it. You could distribute the -3 to both of these first. You could bring this up and make it positive first. I would probably distribute this first. If I move this up, notice it's going to become negative anyways, and it's going to go back down. So I would distribute this first. Remember, an exponent to an exponent is multiplied. 2 times -3 is a -6 over b. -2 times -3 is a +6. This one is positive. This one's negative, so it needs to get moved down. Now, a lot of times students aren't sure what to put on the top then. Remember, when there's no number, this is a 1. So the 1 stays there and the a moves down, so that it gives us 1 over a to the 6th, b to the 6th. Any questions on that? Okay, 9 over 100 to the 1/2. Remember, well, fractional exponent is a radical. So that's the same as the square root of 9 over the square root of 100. Also, when you have a fraction, you can take the square root of the top and bottom separately. You don't have to put either way's correct, but you can think of doing them separately. 9 is 3 times 3, so the square root of 9 is 3. A 100 is 10 times 10, so the square root of 100 is 10. And these are values you can check in your calculator. A basic calculator would do these. Any questions on that one? Eight to the 1/3 means the cubed root of 8. And 8 can be written as 3 numbers multiplied together, 2 times 2 times 2. So the cubed root of 8 is 2. Any questions on that? I'm trying to pick which ones to do. Okay, 4 to the 3/2. What that's telling us is the 2 means square root. So we could take the square root of 4 and then cube it. Or we can take 4 cubed and then take the square root. Now, if we didn't have a calculator, 4 times 4 times 4 can get pretty large, and then you have to take the square root of it. So whenever you can do the square root first, it's simpler, because we know the square root of 4 is 2. And then 2 cubed, 2 times 2 is 4 times 2 is 8. And I think it's a little easier. Now doing it this way, 4 times 4 is 16 times 4 is 64. And then the square root of 64 is 8 times 8. So either way, you're getting the same answer. But depending on what this number is, or this exponent, this could get pretty large if you're not doing it with a calculator. Any questions on that? This one. Now we have 2 radicals, but you can't just combine them because the radicals are different. This one's a square root. When there's no number, it's a 2. And this one's a 5th root. So you need to be careful of that. We can't combine them. You want to rewrite them as radicals. So the first one is x to the 1/2. The second one is the x to the 1/5. Notice when we have the same base, we have to add the exponent. So we have to add 1/2 plus 1/5. Well, in order to add, you need to have a common denominator. In this case, our common denominator would be 10. So we have to multiply this by 5 over 5. And this one by 2 over 2 to get our tens. Multiplying across, we'd have 5 over 10. Plus here we have 2 over 10. Now that you have the same denominator, you can add the top. On a test, this answer is fine with me. I'm not sure if MyLabs will take it. The one they're showing, they want the radical. The 10 in the denominator becomes your radical. But both of these are simplified, and I would accept either answer on a test. Any questions on that? Now, if you want to do the negative first, 1 over, write it first. This is not a nice problem. Oh, cubed root. Yeah, it is. It's not bad. The bottom is our root, so it's the cubed root squared. So you could take 27 squared and then take the cubed root, or take the cubed root first and then square it. 27 is 3 times 3 times 3, or 3 cubed. So the cubed root of 3 cubed is just 3. And then 3 squared is 9, so you have 1/9. Any questions on that? You do need to understand this a little bit, because if you just plug this into your calculator, you're going to get a fraction. And unless, I mean, a decimal, unless your calculator will go back to a fraction. Is there any questions on those? Positive.